What a wonderful afternoon to be studying Algebra 2. Welcome. We're going to look at lesson 9.5b, lot of fraction. We're two methods for doing these problems. Method 1 will feel new yet short. Method 2 is going to be familiar but takes longer. So you'll get to pick. In method 1, this is the new part. We're going to multiply by 1 in the form lowest common denominator divided by lowest common denominator. And if you survey and take inventory of all the denominators, you'll come to the conclusion that the lowest common denominator would be x times y. Basically multiplying all of the denominators together here and obtaining the lowest common denominator. So the shortcut approach is to multiply by 1 in the form lowest common denominator, xy over xy, LCD over LCD. So the advantage of this new method is that when you distribute x, y to each term, and even though it's not required on the homework, I'm going to show the arrows of distribution in green. I'm going to distribute x, y by multiplication to both terms upstairs. Notice how on the first arrow of distribution, the x's are going to cancel, leaving us with only a y. And on the second arrow of distribution, no cancellation, just 3xy. So that's the upstairs distribution. I'd like you to try one of these. Would you please distribute the LCD, the lowest common denominator, to both terms in the denominator? Give it a go. See what you come up with. All right. Now, what do you get on that first farthest arrow of distribution? Is there a volunteer who would like to tell me what you get when xy goes to 5 over? Yeah, or, yeah, question, go ahead.
How did you get xy?
Xy, what I did was I surveyed the denominators, and I noticed one had an x, the other had a y. So the lowest common denominator is going to be, I look at the prime factorizations of all the denominators, and I'll get you. And I just, I'm basically anticipating what would happen if I were to doctor all of the denominators up so that they were common. So does that answer your question then? And then, all right. So who's got the, in fact, both terms. What does the denominator end up being when you complete both arrows of distribution? Owen, go ahead.
2xy plus 5x.
Yeah, so in that first arrow, you get the 5x, and this shorter arrow of distribution is 2xy. Now, we could, it's an acceptable final answer. The nice thing about this approach is that it's fast, you can get the answer in one step. Now, it's a good discipline to factor both the numerator, just in case some additional canceling might occur. Notice how the denominator has a common factor of x. So, there are some ways in which this answer is preferred, but both are acceptable. Notice I just factored out a y, factored out x. Question?
What happens like when you distribute the xy to the 5 over y? Why isn't it like y squared?
Yeah,
Y.
I'd like to show what's actually happening here. The question is, what's happening on this distribution of xy to 5 over y? What's happening is you're taking 5 over y and multiplying it by xy over 1. I didn't show this work, but this is the justification for my answer. You see, the reason it's not y squared is because one of the y's is in the numerator, the other y is in the denominator. They cancel. And so, I mean, if you want to show this step there'd be 4 of these steps to show, one for each arrow of distribution. Then you're more than welcome to do that. So just to clarify, if you want to just show the work on this, then it'd be 1 over x times xy plus 3 times xy over 5 over y times xy plus 2 times xy. And these 4 occurrences of xy are the effect of distribution. So here's showing the work. I didn't show this step. What I asked students to do was essentially cancel the x's in their head to get y. Nothing to do here. Cancel the y's in your head to get 5x. And no cancellations here. Further questions on method 1? So it's more of an advanced, kind of a shortcut method. Now, some of you may prefer to do these problems using method 2. I'm hoping you'll master both of them. I'm just going to put this down here in a cloud. It's not a sound cloud, it's a mind cloud. This is what's going on in your mind in order to get from here to there. Okay, now, the other example is more familiar, it's more work, but some of you may just feel more comfortable with it. Here's method 2. I'm going to take the numerator divided by the denominator, which is 5 over y plus 2, and then just doctor things up. Like the numerator can be doctored up by multiplying 3 by the number 1 in the form y over y. I can doctor up the 2 to get a common denominator over here, y over y. So yeah, this is much more closely related to the work we did on last night. So, oh, wait, hold on a second. I actually realized I messed that up because the common denominator is not y. Let me just fix that. The common denominator over there would be x. So fixing that, the original problem was 1 plus 3 divided by, okay, so instead of doctoring with y over y, I should have doctored it up with an x over x. Okay, now I'm going to get the common denominators I'm looking for. So this fraction becomes 1 plus 3x over x. And I'm going to do 2 things at once. Not only am I going to add these together, but I'm also going to change division to multiplication. So instead of 5 plus 2y all over y, it's going to be y over 5 plus 2y. So I added and flipped all in one step. Hopefully you're okay with that. And looks like there won't be any canceling. Just multiply the numerators together to get y times 1 plus 3x. And multiply the denominators. Notice the answer is the same as method 1. It's just that this method is just more connected to what we've been doing recently. Now, just out of curiosity, at this point, how many of you find yourselves leaning towards hoping to do method 1 on tonight's homework? Okay, thanks for putting your hands up. And how many of you are thinking, no, I'm just going to do method 2. I'm just going to do method 2. No one's indicating, for those of you watching at home, no one's indicating that they like method 2. So everyone seems to be drawn towards method 1. Let's go on to the next page. Okay, you method 1 people. So we're asking you to master both of these. So, by the way, what do you think the lowest common denominator would be in this particular problem? Jonathan?
Wait, I just have a question. You said you want us to know both of these. Are there some problems that we can only solve using one method? Or will it not really matter?
Well, I mean, I haven't looked at the Unit 9 test yet, but I would be shocked if they dictate to you a required method. It's basically going to be, if you can pull this off, go for it. Pick one method and do it. So I don't anticipate we'll be dictating methods. I mean, to dictate methods, we'd have to name the methods. If the method doesn't have a name, how can we put it in the directions and say, you know, use, I mean, people aren't going to go around memorizing like method 1, method 2. That would be crazy. Cray cray, as the young people say. Okay, so it's just not going to happen.
In 2012?
So.
Ooh, don't trip.
I'm still practicing what the young people do, and my trainer is Edward.
Edward. Edward James.
I'll just have to go home and practice a lot more. So.
Maybe try one more time. I think you're third time's a charm. Third time's a charm. Yeah.
Needs a lot of work. It needs a lot of work. Okay? All right, so here we go. Question. What do you think the lowest common denominator is going to be in this problem? Okay?
Example 2.
Practicing multitasking up here. What's the lowest common denominator going to be? I'll take a volunteer on this one. Just inspect all the denominators. Gerald, no? Yes? Yeah, try it. Try it.
I mean, I do have a question. How did we find the lowest common denominator on the first problem?
Sure.
So that maybe I could come up with an
Yeah,
answer.
well, no, that's, I'm really glad, yes. What you can do is take inventory of all the denominators. One of the denominators is x. Here's a thinking process for the lowest common denominator. Another denominator is y. So what you have to do is combine the prime factorizations, ends up being xy. Now, sometimes examples are too basic to be helpful. Sometimes you need a harder example. What if one of the denominators was 3x to the 4th y, and another denominator was 9x to the 3rd y to the 7th? So thinking of prime factorizations here, like where 9 is 3 squared, I would have to have, in the lowest common denominator, I would have to have a representative of each prime factor. Like 3 is a prime factor, and I'd have to take the largest exponent on the prime factor 3. Here's 3 the first, 3 second. Which one do I pick? I pick 3 the second. Now there's an x in both. Which is bigger, x to the third, 3 or 4? I would have to take the bigger of the two, 4, and they both have a y. But again, I need to make sure that when I look at both of the denominators, all of the prime factors from both denominators are represented with their largest exponent. Okay, so for the y's, what exponent should I use on y in the LCD?
7.
7. Okay, so that's, sometimes the harder examples are more helpful in terms of seeing what the general process is. So when we do that over here, again, these problems we're working on here are not super tough in terms of calculating the lowest common denominators. So Gerald, do you have an idea now?
I will say 3 and y. I don't
3 and y, no, that's it. See, all you have to do is take inventory of all the denominators, which in this case isn't much work because there's only one denominator on the inventory list. So that is going to be our lowest common denominator. And so that means that when you're seeking to multiply by 1 in the form lowest common denominator over lowest common denominator, it's just going to be 3y over 3y. So let's give that a go. See if you can execute method 1 in example 2. So all day today, I've had students crowding around me asking, can we cancel the 3 with the 15 to get a final answer of 5y over y minus 1? What do you think my response has been to the request to reduce this to that? I've been saying no. I've been saying, look, cancellations of like factors, top to bottom, numerator to denominator, occur only when both numerator and denominator are in factored form. And 3y minus 1 is in what you could call termed form, even though termed form is not an official mathematical phrase. It's not factored form. You know it's in factored form when all of the minus and plus signs are in parentheses. So if this were 3y minus 1, and then we had a 15 there, yeah. So it's not okay. Do you have any questions on method 1 here in example 2? This is as simple as it gets in terms of the simplified answer. Now, so just to make sure that in case you want to use, some people might want to use method 2, but they notice that so many people use method 1 that maybe you just didn't want to raise your hand and be the only one raising your hand saying, I want to use method 2. So for those of you secret method 2 users, let's write this as 5 divided by 1 minus 1 over 3y. And class, go ahead and humor us. Humor the method 2 users by actually doctoring up the number 1 so that you can subtract fractions.
That was close. You're getting better. You almost got it there.
I try to learn something new every day. No, it's gotta be, there's a knee bend.
Wait, do it. Do you want to learn today? Do you want to learn something?
This is the new thing I learned today.
Oh.
It's what they tell me the young people are doing. Let's just do what we can to keep this little snippet from going viral, okay? I don't want this to be my legacy. Okay? So when you,
No.
3-1. So when you doctor this one up, it comes out to something like 5 divided by the fraction 3y minus 1 all over 3y. And since division is multiplication by the reciprocal, we can think of this as 5 times 3y over 3y minus 1, thus giving us agreement with the method 1 approach of 15y over 3y minus 1. Any questions on that one?
Wait, can we move over a little
Oh,
bit?
yeah. Can I move? What, you're asking me to move?
Not like that.
Oh, different kind of moving. Second call for questions on example 2. Okay. Now, is this our last example of the day? Okay, you can use either method. I don't care which method you use. Go ahead and pull something out of the hat to get example 3 done. Give it a go. I'm just going to tour the room, see how you're doing. Either method. So using the newfangled approach, multiplying by 1 in the form LCD over LCD, is there a volunteer who'd be willing to tell me what the first arrow of distribution would produce? Well, the second arrow later, but the first arrow, this longer arrow, would give you what? Volunteer on this? What does the first arrow give you? All right. Well, yes, Anna, go. If you take x plus y,
X plus y.
it gives you x plus y. Yeah, we were just doing the old multiply by 1 routine, so it's x plus y. And the second arrow distribution does result in a cancellation, leaving you with only what class? 2. Yeah, when you take x plus y and multiply it by 2 over x plus y, the x plus y's are gone. They actually cancel out. If you want to know what's going on in your mind, or in my mind, that second arrow of distribution is where the x plus y's cancel, leaving you with 2. And there's really not much more to do after that. Either way you do it, either method, you're going to end up with 4x plus 4y over x plus y plus 2. Any follow-up questions on example 3? Good work. Give you the next 17 minutes to work on the homework. Have at it. Enjoy.